I'm Georg from Door Labs and StarkNet Asia. So we reached 500 plus registration, and this is why I start my talk, because less person, less pressure. Okay, cool. So super happy to have you guys all here. Like I said, I'm Georg from Door Labs, and also StarkNet from StarkNet Asia. So StarkNet Asia runs several conferences before. So the first one was Stark Tokyo, and second one was Stark Seoul, and third one was Stark Ho Chi Minh City. So actually we did two more before StarkNet Asia. We run the StarkNet, Cairo meetup last year, Seoul, and we also run the Cairo bootcamp last year when StarkNet used Cairo 0. So yeah, meaningless right now, but anyways. And we are also hosting we will have Stark Singapore during Token 2049, and we will also have Stark KL during the East KL. I believe Danilo will be there too, but he's not here, okay. And we were gonna do we are kind of discuss about Stark Istanbul during the Dev Connect with Starkware. And if you interest our events, you can go to check out our event in starknet.asia website, or you can scan this QR to join our Telegram group chat. Cool. So what Door Labs do? We made a ticketing platform on StarkNet, and I believe you guys are all here, which means you guys use the Stark Pass. I'll show you the demo, and I'll explain the flow of our application. Yeah, so this is a admin page, so people can upload their own events. So, yep, put some details here. Dates, locations, and yep, tickets, add some description, and save it. So when you make an event on our platform, we store the event data on chain, on StarkNet. And after that, I'm pretty sure you guys all know how to use our platform, but when you logged in and when you get your ticket, we stored your data on chain with the event info. So, and after that, when you came here, like a few hours ago or a few minutes ago, we scanned your QR code. And what we are doing here is check your data on chain, on StarkNet, using a view function, and check you are already registered or not. So when we store your data, we hash it your data and store it. And after that, we send your plain data, which means let's say if we hash your ID and store it, then we just send a plain ID QR and then send it to the view function and calculate hash on it and check it, is this data already stored or not. So if it is stored, which means it's registered. So this is the basic flow. So And now I think I should say why we made this program. So a few years ago, I thought like blockchain has a huge potential, but still, I think like we need much more, several years to much more people use the blockchain. So I thought, okay, maybe I need several years to make a smart contract. But Door Labs comes out. Door Labs told me that we have a partner who runs one of the biggest offline entertainment company. They sell like few 100K tickets per year, and they want Door Labs to make their ticket to NFT. So when I heard that, I thought like, okay, could work, but really? So Door Labs did a kind of POC thing project. So Door Labs sold the ticket for a concert, and the price is around like $120 or $110 or so. But this ticket sold out less than 30 seconds. So the 300 tickets sold out less than 30 seconds, and it was NFT. So we kind of found out the potential of this market. And after we saw the statistics of the customers, it was quite amazing. Mostly women in their 30s to 60s, which is not a typical crypto user at all. So here we are again. So we saw the potential of this ticketing platform, but the problem is most of the users are women in their 30s to 60. So how can we make a ticketing platform for them? How can we make people to make their own wallet and make a transaction like that thing? We really struggled to find this answer, and our answer was just remove the wallet and transaction thing. We hide it. So Door Labs store the events data, and Door Labs store the registration data. Then why should people use our platform? Why? Is there any benefit for using this platform? So after you use this ticket, we stored your data we change the status of your ticket to used. And if it is used, you can claim NFTs as a proof of attend. And I believe in Korea, ticket reselling is illegal. I think we can find an answer because this ticket is basically code, right? So if you want to check out more, you can go to StarkPass. And if you want to list your events on our platform, please feel free to ask me or the BC that wear Door Labs t-shirts. It'll be great. Yep, here's my talk, and thanks. If you have any questions. Yep. Thanks. Yep.
Yeah. Here you go, bud.
Yeah, of course, sure. Hey, so I just have a quick question. As you mentioned in your talk, you just hash the data and then send it on Starknet network. My question is, how does it work with all the gas? The gas.
Yes.
Yeah. Does Door Labs pay for the gas? As the guy who created the event has to do some gas provision to do the execution? How does it work?
Okay, so first of all, I need to mention that our platform is not on a mainnet. It's on testnet at this moment. So first of all, the money is not real money. And second of all, we don't store the whole data of the user. So like you guys type the like GitHub like username and like Telegram handle, Twitter handle like that, but we don't store the whole data. We only store the like one public data to hash it and store. So like in gas wise, it's quite cheap. I'll say it's quite cheap. Yep.
Okay. I just have a question based on that. So is the application supposed to stay on testnet the whole life, or maybe one day you will have to go to mainnet and then pay for the fee? What is the current next step for you?
Yeah, right. Okay, I'll say that's a good question related to the business model. So right now we only do the free ticket thing. So, but like I said, we have partners, and that's why we make this platform. And that ticket will not be free. So we will get a like few percentage of the whole like price. So we will cover the gas price with that. Yep.
Thank you.
Thank you.
Hello, everyone. I'm Guilty Gyoza. I'm a co-founder of Topology, and today I'm here to talk about Shoshin. So the company was founded towards the end of 2021. We hypothesized that blockchain is a new medium to design a new kind of video games. And it's because it's a new kind of video games, it takes a lot of experimentation. So we've been looking for the Angry Birds moment for fully on-chain games since the genesis of the company in 2021. We've done some prehistoric experiments. So October 2021, we ran physics simulation on Starknet. These are numerical simulations that can compute the dynamics of physics systems over time. We also did some very primitive AI experiments. So on the right of the screen, that was a two-layer deep neural network fully represented in Cairo 0 small contract that was able to run inference on the MNIST dataset. Test accuracy was only 94% because it's a small deep neural network. But nevertheless, we thought it was a lot of fun putting deep neural networks on a blockchain. And then fast forward to roughly April 2022, we conceived of Shoshin. So it is like 0x Monaco, but for fighting game, and there's no programming required. For those of you who may have not came across Monaco, 0x Monaco, it was a fully on-chain game by Paradigm, where you submit Solidity bytecode that basically represents the strategy in a racing car game. So we created this asynchronous on-chain game that has the fighting game loop, and we wanted to make it so that the game can be playable by players that have never programmed a computer in their life. So the game idea is that player will create strategies, and the strategies will be put inside a 2D box that will fight 1v1. And once you create the strategies and submit the strategy, your hands are off the keyboard. We spent roughly a week writing Cairo 0 small contracts as a proof of concept for Shoshin. And this was roughly June 2022. So what you're seeing here is we reused Q's art assets from the King of Fighter games to represent the fighting characters. And we have the Cairo 0 small contract set up so that every single frame, our contract computes what each strategy decides on the action. The action would drive the animation state of the characters. The animation state of the characters would then translate to hitboxes by the physical hitboxes and the active hitboxes if they were actively attacking or defending. These hitboxes would go into a physics simulation that run fully in the Cairo VM. We did very simplistic physics simulation. This was first order physics using fixed point arithmetic. And then a bunch of other things happened. Fast forward to January 2023, we decided to pick Shoshin back up and give it a fair run. So we fleshed out the smart contracts more. We built a web app front end to visualize the fights. So what you're seeing here is the really early days of Shoshin front end rendering layer, which is fully in HTML. The characters are just div tags, and the hitboxes are rectangles. So the early days of Shoshin, we exposed the Shoshin computer to the players. What we mean by Shoshin computer is that strategies in the Cairo smart contracts really are represented as finite state machines, where the transition functions between the states are binary expression trees. And despite us wanting the players to not know how to program, in the early iterations, we exposed the entire Shoshin computer to the players. So players have to craft decision trees with if-else branches, and they have to craft expressions that serve as the conditions that the strategy will use to switch between different branches of the strategy. And this was obviously programming all over again. So we went on a long journey of trying to abstract this more and more so that players feel more comfortable despite not knowing how to program. And we ended up with this structure as of now. This structure was directly inspired by the Final Fantasy XII game, where the game has a system called the Gambit system. And the Gambit system basically is a strategy that is expressed in a linear form. So every layer is like a thought in your head. And a layer will have a condition and an action. So if the condition comes true, you perform that action. And so you can see here we have layer 2, 3, 4, 5. For example, we can take layer 4, for example. Layer 4's condition is if my opponent is knocked, and also if I am within 120 units from my opponent, then my action will be a mix-up, 50% upswing and the other 50% probability moving forward. So we have these abstractions that we think would boost player productivity by a ton. And there really is a mental model. I think Gyuk finished the talk early, so I will explain this slide a little bit more. So we have this mental model called the Kolmogorov complexity. And the Kolmogorov complexity is this thing in theoretical computer science that says, given a programming language, given a target output, the size of the minimal program you have to write to produce that output. Okay, so for example, given the target of, let's say, a binary sort algorithm, if you were to implement this algorithm in brainfuck, then you will be writing a long program. It is not really readable. But if you were given JavaScript, then the program would be really straightforward. So the JavaScript, the Kolmogorov complexity of this problem, given JavaScript, the programming language, is really small. But the complexity is really high given the brainfuck language. So really the programming language here, the expressivity of the language matters a lot. And we want the Shoshin editor with which players describe the strategies of their fighting to have as low of a Kolmogorov complexity as possible. So that really is our objective. And although we've been using this sort of linearized system from Final Fantasy XII, we will continue be abstracting this interface more to have more expressivity. And just a slide on the technical overview of the game system. The physics really is a very simplistic sort of system. This is like 1980s sort of era video game physics, where we have fixed point arithmetic, because in Cairo, I think floating point is still very expensive. Fixed point is easy to do. 10 decimal points, I believe, is the precision that we ran with. We have first order physics simulation, because in video games, unlike real physics experiments, you don't need that much precision. So we run first order physics, also known as the Euler method, where you take acceleration and you update velocity, and you take velocity, you update the position of all the hitboxes. We have a very simplistic two-step collision detection and resolution. So in any game physics, there needs to be collision detection and resolution if you want things to interact amongst each other. So for example, if I have a So if one character runs into another character, what really is seen by the smart contract is their hitbox overlapping. And our system, pretty simplistic, we approximate each character by a single rectangle. So for those of you who may have played modern fighting games, Street Fighter, Skullgirls, Guilty Gear, etc. They have a lot of rectangles approximating the shape of the body, but we are just prototyping this game for the first time, so we have a single rectangle approximating the shape of the characters. And if the character is like punching or slashing, we have another rectangle that represents the range of the attack or the range of the defense. And then so collision detection really is about detecting if these rectangles overlap, and if they overlap, we need a way to resolve conflict, because we don't want rigid bodies to be overlapping in a physics scene. They will always stay apart from each other. But unlike in this reality where rigid bodies are sort of repelled against each other because of electromagnetic forces or some more basic particles, in physics, in game physics, we need to write mathematical programs that can resolve by pushing the rectangles apart from each other so that they stay away from each other. So that was really implemented in Cairo 0. And on the agent side, every agent strategy is represented by finite state machine. And finite state machine is just this really straightforward mental model that we have. So finite state machine is, if I am in the neutral state and if my opponent is offending me, I go into angry state. And if I'm in the angry state, I would perform a kick or something. Then transition functions between these states are expressed by binary expression trees. We need a flexible way to represent these functions in our Cairo smart contract, because what we're really doing is we want players to submit strategies. And these strategies are programs that are being computed by our core engine, our computer. And so we need a way to represent these functions, and binary expression trees is our choice of representation. And finally, we have animation state, which is represented by finite state machine. This is the common sort of industry practice. If you've used Unity engine or Unreal Engine before, animation states are anim state machines, literally finite state machines. And finally, everything was implemented in Cairo 0 and still is to this date. So fast forward to July 2023, we ran a in-person playtest in Paris, where 25 players tried Shoshin. And this was only campaign mode. So campaign mode is where we give you opponents and you fight the opponents in completely deterministic manner. And throughout the playtest, we received requests for PvP or online PvP or on-chain PvP, because if you play fighting game before, all you really want to do is you want to finish the story or the campaigns or the tutorial as fast as possible, and you want to battle other players. You want to beat their ass. So we received this request and we fulfilled their wishes. This was August. We added online mode. Online mode is where you can submit your agent, which can go into fight with other people's agents, directly player against player. So then we run a tournament, because we have this hypothesis that fighting game is where agent battles agent. But we, strictly speaking, don't know if this game loop will work in a player-to-player format. And so we need to test it. So we ran the Shoshin tournament, the first ever tournament of Shoshin in Stanford, around the time of Stanford Blockchain Conference, which was only last week. The tournament was run on August 28th in AC Hotel Palo Alto, where the Starknet Hacker House was hosted. Okay, but there's one problem. So if agents are deterministic, you run a fight amongst them, it's completely deterministic. So there's one fight, and that's it. If you run the second fight, it looks exactly the same, because everything is deterministic. And that really isn't helpful for tournament, because you want to watch more dynamic outcome. There's drama of people coming back in the next fight and so on. With deterministic agent, you really can't have that dynamism. And so we added mix-ups. Mix-ups is where you play fighting game, you want to be unpredictable. Every time a situation happens, you want to do something, but maybe also something else, so that you're not really easily guessed by the other player. Okay, so without the mix-ups, if you do low kick, you always do low kick. But with the mix-up, you can specify the probability of actions in a single layer. So once you're in that layer, you can have two different outcomes depending on a random number sampled in the Cairo smart contracts. That was a pseudo-random number. And the number is sampled from a hash function. So really, it is a uniform distribution. You can say, I want to do 10% action A, 90% action B. And every time you go into that layer, the random number will get generated freshly, and you will do something randomly. And so with non-deterministic behavior, what we really can do in a tournament is we can have lives. So we can do best of 3, right? So this is 1v1, and we do rounds after rounds. Whoever wins 2 rounds first wins the entire game. And because our agents are non-deterministic, there's randomness. Every fight looks slightly different, and there's opportunity for comebacks, which is great for generating drama. Okay, so tournament structure, simply speaking, it's a double elimination bracket. Players fight amongst each other in a best of 3 format. In between the game, you can resubmit your agent, because if you lose to an agent, you see patterns of other agents' behavior. You can resubmit your mind with tweaks so that you may come back with a better behavior later. And the results was pretty cool and pretty surprising to us. There were nail-biting comebacks, which means that you have players that went to the losing brackets and went all the way back up to semifinals, which is amazing. And it was really time efficient because we were able to run double elimination brackets, best of 3 fights with non-determinism, 15 matches less than an hour. And underdogs emerge, which means that there are strategies that look very inferior to most other strategies, but they happen to beat the dominant strategies that happen to overpower all the other strategies. So there was a lot of this dynamism, which is really cool. And the dominating performances was this is the championship fight between Jack and Beha. The fights were coming back and forth. Best of 3 rounds, where the first round was, I believe, Jack won the fight. The second round was Beha winning the fight. And so it comes down to the round 3. And this was only possible because there's non-determinism. We have roughly 40 players attending the tournament, 13 players competing for a championship. And we make them rocks, basically trophies in the form of rocks for the number 1 and number 2 players. And it was a lot of joy for players watching their agents performing fights like a cinema on a big screen. And players were really proud of their achievements. So that was really cool, them tweeting about the tournament experience. So lastly, I want to talk a little bit about what does all this mean for StarkNet. This screen encapsulates a lot of our experiments at Topology since the genesis of the company. On the top left, you can see Isaac, which is a 3-body problem physics simulation in the Cairo smart contract. On the bottom left is the login screen of Shoshin. On bottom right is the Mumu, which is another experiment we did about digital alchemy and sort of this pipeline of emojis transforming into other emojis as a fully on-chain simulation game. We think that StarkNet gives you verifiable compute via validity proof. And with all these sort of compute surplus in the blockchain space, it's interesting to find good uses for those verifiable compute. And we think that interactive storytelling, interactive entertainment simulations is a really good way to transform those verifiable compute into new kinds of experiences. And so that's why we've been running all these experiments, and we hope to find new paradigms and new applications that could be possible on the blockchain. So for those of you who are gamers, go play Shoshin at shoshin.gg. And those of you who are not gamers, you can follow along our journey on Shoshin_GG on Twitter. Thank you, everyone, and welcome questions. Yeah.
Is this the trick that kind of like the players submit their strategy on beforehand, and then because the L2 block is like newly generated, and then like block cache is totally random as a like future. So because of this time gap, you can get the randomness very fresh and non-deterministic or known by someone else from beforehand. Am I understanding correctly?
I think half and half. Our entire Shoshin game loop runs in a single transaction.
Okay.
So it's a single block interaction with StarkNet.
Then how then you generate the randomness? Because as far as I know, StarkNet don't have a randomness in the native. So
right. So our randomness really is can be understood as game randomness. When you play video games, there's something called seed, and when you're given a seed, you have all these outcomes. If you change the seed, you change the outcome. But if you use the same seed, you'll get the exact same outcome. It's pseudo randomness that is a function of seed. And if you don't throw in any other sources of entropy, then the same seed will give you the same outcome, which is great because we can reproduce fights if you remember the seed. So given the same two agents, we can say seed 77 gave us a lot of amazing fight. Seed 11 was like a 2-0 fight, less drama, and so on and so forth.
Yeah. Oh, okay.
And then, so it comes down to choosing the seed, right? That is sort of fair to both players. But this is really another layer of game loop on top of the Shoshin game loop. It's about choosing the seed, and there's attack and defense. And so we want to push out a on-chain PvP protocol in the next 2 months, hopefully, so if I can attack you, and rationally speaking, I will choose the seed that optimizes my chance of winning. But there can be a path of view, basically rebuttal, and you can choose the seed that works for you best. And that concludes the fight. So we don't really need, maybe in DeFi protocol, true randomness. Yeah. We just need randomness that makes sense in a game setup.
Okay, understand. Thank you.
Why did you guys build this in Cairo? What unique feature of Cairo that makes it very suitable for building this game?
So this game was built in the Cairo 0 era, and I think we came across Cairo as this very low-level programming language that is low-level than Solidity, but it's higher level than Circom, which is the other dominant language for writing zero-knowledge circuits. Circom wasn't really productive if you want to write big game loops. Cairo was low-level enough so that we understand what everything is going on in the VM, and it's just that our internal team developers didn't really like Solidity as a programming language, and so we chose Cairo. I do think that the entire Shoshin game loop, if we want, can be reproduced in Solidity. But it's just that we think that the EVM space has a lot of interest and stake involved. And so the innovation is kind of complicated. But in the Cairo space, things move around more freely because it's a newer ecosystem. So we get to screw around a lot more and do weird stuff. I think that's primarily the reason why we chose Cairo, not out of sort of technical superiority. But of course, if you're in the StarkNet ecosystem, there's this concept of fractal scaling and recursive proof. All of that gives us more confidence that we can run more complicated Shoshin, so that we can run Shoshin fights off-chain, and you can recurse the proving so that you're rolling the proofs and you send the proofs on-chain for verification. That allows you to run longer fights among more complex strategies.
And also that now Cairo 0 will soon be deprecated. I guess we'll be migrating to Cairo 1.
Yeah, so we have been troubled by this a lot. It was only because our bottleneck really is on the front-end side, where we want to improve the editor interface, the Kolmogorov complexity thing. But we are aware that Cairo 0 will be outphased. And we decided that instead of a rewrite, which is a little bit boring because keeping the same feature set but re-implement it in a new programming language feels like work. So if we're going to write a new game in Cairo 1, we'll just write a new game. So I think the current idea is we take Shoshin, we slap an on-chain PvP protocol on top, and we call it Shoshin. And we will move on to Cairo 1, fresh front end, and make a new game. In terms of what the new game look like, we don't know.
Oh yeah, and one more. Would it be possible if you built this using something like Dojo, for example?
Well, I think nothing is impossible. I think that what will likely happen is that we will study the Dojo code base. Primarily, I think how you abstract the ECS pattern and how you do code generation. Whether or not we will use Dojo is, I think, undecided. But I think we'll be heavily inspired by your pattern. I think that's the likely outcome. Okay, if there's no question, thank you, everyone.
Hi, this is AJ, founder of Radius. Radius is building shared sequencing layer for rollups to enhance rollups into Ethereum. I started this project about around a year and a half ago to build MEV resistant AMM. We started as a Ethereum Foundation grant. And then a year ago, we kind of pivoted to build sequencing layer with the same tech that we used for Ethereum Foundation grants. So today I will talk about the Today I will talk about the Madara, which is the rollup SDK. It's kind of as known as Starknet stack, and then we will. Radius is implementing an encrypted mempool and also shared sequencing layer module for Madara. So any developers who wants to build their own rollup network on Starknet can use encrypted mempool or external sequencing layer. So many people said that rollups aren't real, but we think it will be soon. So because Starknet is one of the most promising ZK rollup as a layer 2, and then you can use Madara to build your own like a app-specific chain as a layer 3 or any Starknet rollups on top of the Starknet. So before going deep into Madara and Radius, I'd like to talk about why we should care about rollups. So actually, many developers are right now implementing their dApps as kind of a smart contract because it's kind of easy. There are a lot of code base that they can refer to when building dApps on Ethereum but the only thing that these developers care about is just the business logic, nothing else. So it's kind of easy. But rollup is different. There are something that you should care about when building rollup network, which is the sequences, like operators. So you need give some kind of incentive to these rollup operators to make your rollup network running. So we call it as rollup economics. So it's also business. So they need to earn profits or money to run these sequencers or operators. So we make sure that your rollup network is kind of sustainable in economical way. So there are two ways to make some profits from this rollup network. One is the transaction fee, and another one is MEV. The rollup is kind of all about the scalability. So transaction fee should be kind of much lower than base layer on Ethereum. So rollups actually can't make a big profit from this transaction fee. Actually, right now they are not making any money from this transaction fee. So they are looking for some kind of alternative to make some profit for running their networks. MEV was one of the good solution for them. So, but there are some problem on that. The problem is the economic trade-off. These days, these sequences are really centralized, so they need to make sure that they don't do any bad behavior on users' transactions. So they say that they process transactions first come, first serve. So there's no. They say that there's no bad MEV. There's no harmful MEV for users. So which means that they cannot make any profit from this transactions fee or maybe. So it's kind of users protection thing. But the problem is that, as I said before, they need make some profit from this to run their networks. So they can look for some MAV monetization thing, but right now there are no such way to do that. So to solve these problems, right now, rollups are looking for some way to decentralize the sequences. Right now, sequences is really centralized, which means that they can do whatever they want, like extract a bad MEV from users' transactions, or also they can censor transactions. So they want to make sure that decentralize the sequences. Probably the common way to decentralize the sequences is to apply consensus model. But rollups is all about the scalability. So putting this consensus thing into rollup operators might put some overhead, some latency when building a block. So also these sequences, even though these sequences are decentralized, the transactions are transparent, which means that sequences can still check out the contents of the transactions and then extract some bad MEV from these users' transactions. So we need some kind of protection for them. So Radius builds encrypted mempool to protect users from harmful MEV. So because these transactions are encrypted when building a block on sequencer side, so we can remove this. We can disempower the sequences, so they cannot do any bad behavior such as a censorship or harmful MEV thing. So encrypted mempool, how does it work? It's kind of simple actually. So, and then these features are, this feature is the one that we are integrating with Madara. So how does encrypted mempool work? User encrypts transactions and submit these encrypted transactions to sequencers. So sequencers cannot see the contents of the transactions. And then while these transactions remains encrypted, sequencers have to confirm the order of the transactions. So before decrypting the transactions, a sequencer makes sure that the orders of the transactions are confirmed. So after decrypting the transactions, sequencers cannot manipulate the order of the transactions. That's the simple way to describe encrypted mempool. But there are some key challenges in encrypted mempool. First one, security on the end user side. Another one is the risk of those attack on sequencer side. The last one is user experience. Security on user side means that we need to make sure that these order of transactions are confirmed while these transactions remains encrypted. So how we can make sure that happens, sequencers can decrypt transactions and then give users order commitments that can happen. So we make sure that those kind of thing does not happen. So, and then another one is that because these transactions are encrypted, sequencers cannot distinguish if these transactions are valid or not. So we need some kind of way to prove that these encrypted transactions are valid without decrypting them. So, and then another one, user experience. I will go deep into one by one. So, as I said before, we make sure that when sequencer confirms the order of transactions, these transactions should have to remain encrypted. So Radius is using delay encryption, which means that time lock puzzle. So the solution to this time lock puzzle will be encryption key. So when user submits these encrypted transactions to sequencers, they also provide this time lock puzzle. So sequencers need to run to solve this time lock puzzle to get decryption key. So that's when this delay happens. So during this delay, a sequencer needs to provide some kind of order commitment saying that your transactions will be included in a specific index of next block to user. So there are some other way to do that, like a threshold encryption model as well, but there are some kind of a trust issue that when you use this threshold encryption model, you should depend on key holding third-party committees. So we want to remove, Radius wants to remove this trust assumption, so that's why we apply this delay encryption thing. Another one is that we need to prevent this DOS attack on sequencer side. As I said before, this is transactions are encrypted, so sequencer cannot see that the contents of that. So we applied a GK to prove that these encrypted transactions are valid without decrypting it. So user needs to submit encrypted transactions with this GK proof. The sequencer verifies this proof, so this sequencer can check out these encrypted transactions are valid without decrypting them. So if this verification on this GK proof is true, sequencer sequencer can start to solve this time lock puzzle to get decryption key. So it's not like a waste of their computing resources. Okay, I put the wrong title over there, but it's about the user experience. But as many of you probably already know that generating this GK proof on user side is kind of it's kind of a computation intensive. So which means that it takes a lot of time, that a lot of computation resources to generate this GK proof, especially like this complex computation like encryption thing. So that's why we developed our own GK-based scheme called PVDE. It stands for Practical Verifiable Delay Encryption. So it's kind of a lightweight to generate GK proof about this whole encryption process on user side. So we successfully managed to generate this GK proof on the web browser. So it only takes a couple of seconds. So it doesn't affect user experience that much. And then we also, right now, we are optimizing this PVD scheme to make even shorter. So we can decentralize this sequencer via encrypted mempool. User encrypted transactions and also generate ZK proof, and then user submits these encrypted transactions to the sequencers, and the sequencers validate this proof and then confirms the order of transactions, and then provide some kind of order commitment to users. And then after decrypting all the transactions, a sequencer actually builds a block and then posts this data on, or give rollups to post this data on that. So another one is that, as I said before, it's encrypted mempool thing is that only kind of to protect users from harmful MEV. But as I said before, there's a rollup economics, which means that we need some kind of way to monetize all the activities on rollups, so we can make these rollups sustainable in the economical way. I'm not going deep too much about that, but Radius is right now we build this block two parts. The top. The first part of this block will include encrypted transactions from users, so the order of these transactions cannot be manipulated. And then the second part of the block will be like will include some kind of transactions, which like arbitrage or backrunning, or even liquidation, which is the good MEV. So based on the first part of the block, we can make some kind of revenue from this good MEV stuff. So we will, as soon as sequencers decrypt those transactions, they publish this bundle to some kind of open market for MEV researchers or traders. So this is kind of a similar thing to like a Flashbots are doing right now. But any MEV researchers or traders make a bundle, and then they submit those second part one with the beads, and then these beads will be a profit for rollups. So this is kind of the simple way to describe what Radius is doing. And then we chose StarkNet as our first layer 2 project to integrate with our encrypted mempool and sequencing layer. So Madara is kind of a rollup SDK for StarkNet. So you can use this Madara to deploy rollups on top of the StarkNet. So it's actually really an important component to realize this fractal scaling vision. So this is the Madara tech stack architecture. There are several tech stack right here. Cairo will be used as an execution stuff, and then like for smart contract or users transactions. And then after this execution thing, these transactions will be proved by Sharp or Stark Prover. It's kind of a settlement layer as well. The Madara will be in charge of these sequencing modules. And then also, Madara is kind of open to any type of DA layer, Celestia, Eigenlayer, or any DA committees as well. So developers who use this Madara SDK to deploy their rollup network on StarkNet can choose which DA they're going to use, or they can do. It's kind of flexible. So you can see the right side of the slide that this is kind of architecture. Here is a sequence is Madara sequencer validates transactions and run Cairo VM and then produce blocks. And these blocks will be delivered to prover, or stock prover or shop. And then this prover generates a proof. And then this proof will be posted on layer 1 or any DL layer as well. And then Radius is provides advanced features for Madara. So as I said before, we are implementing encrypted mempool. So like DEX or any projects who might care about these bad MAV on user side, they can choose encrypted mempool, so they can provide some kind of protection for user side. And also, as I said before, rollup is kind of developers actually just want a simple thing. So when if they want to if they want not to care about the running sequencers or validator thing, they can delegate this running sequencer thing to Radius externals shared sequencing layer. So these two features that we are implementing for Madara project. Actually, Madara is a good thing about Madara is that they didn't build from scratch. They used Substrate, which is the blockchain SDK, which is kind of good. So developers can choose which features they will provide on their rollup network. So they can simply choose features they want to integrate with their rollup network, and then they can get their own rollups. So it supports a plug and play thing. Yeah, this is the last page that I prepared. Madara is right now is really active. It's open source, and they are really actively developing at this moment. So they are compatible with the StarkNet RPC or this this sharp prover also will be integrated with Madara as well. So Cairo 1 is also supported as well. And then Celestia and Polygon Avail, this data availability layer also will be supported on Madara as well. So, and then Radius is doing the encrypted mempool thing as well. And then another one is that they provide a default consensus model for their rollup network, but also they can right now like a Tendermint or Hot Stuff. These other consensus module also will be integrated soon. Yep, this is all that I prepared for today talk. And then Radius will be will launch testnet probably at the end of this year, and then mainnet alpha version will be launched early this year. Yep, thank you so much.
Hello, my name is Pia. I'm from Herodotus. I'm product engineer in Herodotus. Today, I'm gonna present about what is storage proof and what storage proof can solve, and so what is storage proof and what to Herodotus is abstract the storage proof. Yeah. So before we jump on, we need to discuss about what kind of problems that the storage proof solve. We have to think of what is the Ethereum's current state. Before, we store the data like contract address, storage key, and value inside the Ethereum. But we are missing the one dimension, which is time. What if we can actually get the specific contract address, storage key value at the specific block time number, which is now this dimension is lack of current Ethereum state. Okay, so the second one is, as you know, when the Ethereum goes like more sharded, we have a lot of scaling solutions like L2s and rollups, which is StarkNet is one of the one. And which means that we have more options to store the data in like inside the A rollups, B rollups, and there's many like cases that we need to like access per like each rollups. So actually, what we think of it, even though the database is more sharded, we have to access the data, like whether like user have to access the data regardless of the location is the data. Yeah, regardless of the data is like stored, right? So basically, like current Ethereum has like two major like problem, which is time and space. Which is, we believe the storage proof is the best solution that can solve this problem. So what is the storage proof? Now let's move on to like more technical like discussions. To understand what is storage proof, and understand that what storage proofs then unlock the historical data that we just mentioned about the like problem of the time. We need to understand that storage proof enables you to unlock the verify the whole like historical blocks based on recursive proof. So you can basically retrieve the previous block hash through the like current block hash, and you can retrieve it again and again and again until go through the Genesis block. And this part we discussed at the like San Francisco Summit, which is like a few days before. We announced a like big announcement about we can able to borrow the Starkware Sharp as a like first external team, so that we can able to make an off-chain processor to process the whole Ethereum blocks from the almost latest blocks to until the Genesis block, which is crazy. So that means storage proof enables you to access the data from the Genesis block to the latest block. We're doing some, we are accumulate the block hash of the L1 like through the certain like checkpoints. So it will be pretty cool. Yeah. And then like second basic knowledge to understand the storage proof is a Merkle tree. As you know, like Merkle tree is like you hash the data and then you hash it again and hash it again all the way through you go to the Merkle root. And why this is important is because if you know the Merkle root, then you can, when you get the Merkle pass, which means if you have a like data A and if you have a like Merkle root, then Merkle pass, which is to retrieve the A from the Merkle root, itself is a Merkle inclusion proof. Itself is, we can prove that A exists in this Merkle tree. It's like a basic knowledge to understand the storage proof. Okay, so now goes through the storage proof 101, which is core concept is like I just mentioned, like briefly. You can prove any kind of data that exists inside the like Merkle tree, and based on the cryptographic commitment, which is right now the Merkle inclusion proof. So let's move on to this page, and which you can see in the block header, you can see multiple like roots, and let's go through the state root. And state root contains the like state tree, which is like state Merkle Patricia tree, which stores the every like account as in element. And if you click on like one account, which is like, you can think of the wallet or you can think of the smart contract, then you can see the nodes balance storage roots like code hash, and the storage root is the root of the tree, which stores the every values that stored inside based on this contract. So this is like bit tricky. This is how the Ethereum stores the data inside their blockchain. And these steps is the reason why we're abstracting this storage proof in the API and to the turbo. Okay, so like, just to recap, if you want to access the specific value of this storage tree, then you have to calculate the Merkle inclusion proof of this value. And then this account state itself is also stored inside this word state tree, which is also a Merkle procedure tree, which need to calculate the Merkle inclusion proof, which you can retrieve from the state root. And it needs a two-step of Merkle inclusion proof, which is pretty expensive. So that's because that's the reason why we are, as Herodotus, we are building the API and we are building the turbo, which is like one-line query to access the data from the another chain to like another chain using storage proof. And we use some like ZK snark and stark to read and write more efficiently and to store the block headers like using the off-chain to make the cost more cheaper, so that actually user can use our infrastructure on their application. Then you can maybe ask why this is useful. Then we can just say there's many use cases, of course. One of the use cases that we are talking with the SnapshotX is we can actually do the cross-chain voting using storage proof. You can make a proof of the asset, and you, based on like L1 asset, you can do the voting on the L2. And also you can do the identity. You can use your ENS on the StarkNet, and you can do bridging. You can use your Ever AI on the L1 to the StarkNet. And gaming, you can use your L1 asset and make a proof and execute and make a transactions on the L2 game. In this talk, I actually recently prepared the demo page to showcase how to call the Herodotus API in the more intuitive way. So this API is basically abstracting the process that I just mentioned, like very technical part, so that developers don't need to like think about the Merkle inclusion proofs or like ZK snark and stark, etc. So what you need to do is like first, you just need to think about where you want to generate the proof and where you want to use that proof. So in our case, right now we are supporting the Gorilla to like StarkNet or ZK Sync. In this case, I just start StarkNet. And then what block number you want to generate the proof, which is you're mentioning about the L1 block. So currently, our API itself, we have a limitation of about 250 blocks, but this one will be changed soon because of because we are borrowing the Sharp and verify the L1 blocks until the Genesis block. So you can call the block number 0 soon. But now let's do the almost latest block. And what you want to prove. This part is the part that I just mentioned with the block headers and the like stage tree, etc. You can access to the block header, which you have these options. Like block head number, hash, parent hash, all the data that you can access through the block header, you can literally make a multiple proof using our API. And the account, which is you just need to put the account contract that you want to access. Right now, I don't have my wallet, so actually, you can put the ENS in here also. We support the ENS. And yeah, of course, you can add the multiple but the thing is, if you want to do the storage hash, you need to put the Merkle inclusion proof of the specific value inside the storage tree, but this part is, I think, not enough time for this talk, so let's just do with the block header. So, yeah. Just you can do whatever, and then if you want to get the response by the webhook, then you can put your webhook URL, then you can get the response back to your webhook. Or if not, then you just you need to submit the API key. Which is API key. You can get the API key by the GitHub. Which is, I don't think this is my laptop, but I think it's Gil. Yeah, Gil will be able to. Never mind. Yeah, so if you put the Herodotus API key by signing up the GitHub, then you can get the Herodotus API key and you copy paste to the Herodotus API key and then you send it. Then you can able to generate the proof, which is you can read it you generate the proof based on Gorilli, block number this to the Starknet, and the specific property that you ask is block number and proposer. Yeah, that's how we use the API. Yeah, I think that's almost all. So thank you for listening. Do you have any questions I have 5 minutes, so if you have any questions, then yeah, thank you. Oh, yeah, if you can, then yeah, you will be cool, yeah. Thank you. If you have any questions about Herodotus, then yeah, in the meantime, you can go ahead. Yeah, we got one more user in the Herodotus. Generate the proof, and you can get the task ID, which is you can call the status of the task ID. And right now, our API is a little bit slow. But we are optimizing and also doing auditing, and then yeah, we are changing a lot of stuff based on the talk that we do at the SF, borrowing the sharp. So later it will be 5 minutes-ish, then it will process all. I think there's a question, so thank you for listening.
Hello. Good evening, everyone. Okay, I lost. It's very chilly, and I have my sweater on. Quick introduction of who I am and what do. My name is Chi Chuan, or you can call me Chi if it's a bit too complicated. I work for Nethermind, Voyager team in Nethermind, and I'm a developer. So today I'm going to talk to you about Voyager, and the title of my talk will be Starknet Data at Your Fingertips. So for those who are not familiar with what Voyager is, this is probably a good introduction. For those who are familiar, also, I hope that my talk will be able to give you more insight as to how to use Voyager. So, okay, without further ado, let's start. Okay, so these are the basic building blocks of a blockchain. So we have blocks, we have transactions, we have contracts, we have events, and in the case of Starknet, we have messages. So all these things come together to form and have information of what a blockchain should look like. And it's very important for us to get to know them, get to understand what's inside, because these building parts contains the data and the structure that we're interested in. Oops. I would like to draw attention to what we would normally use blockchain for. So back from the era of Bitcoin, the use case of blockchain is just to transfer Bitcoin. So Bitcoin as a store of value, you're transferring the Bitcoin to your friends. So at that point of time, what is important was to know that if your transactions succeed. So over here, I attached a nice screenshot of how it looks like in Voyager. So there are a couple of status. I will go through that later. And also how much is being transferred, right? How much money I transfer to you, that is super important. And the most important thing, who transfer money to me and who am I transferring for? So these are the things that we are normally interested in back in the days of Bitcoin and the early stage of Ethereum, before the advent of smart contracts, so on like that. We can do a lot more magic, which I'll show you again later. So let's imagine like the world without Block Explorer. Right now, we are spoiled with choices, like Etherscan is there. And the first thing you guys probably do in transacting in an EVM chain is to go to like whatever scan, and you realize that the UI, the UX is very similar to the Etherscan we know and love of, because we are spoiled by the existence of Block Explorer. So let's imagine in the case that without Block Explorer, let's imagine how would you decode, how you understand the data that you are interested in. So let's look at a transaction. This is how a transaction in Starknet will look like. Let's say if I were to interact with a contract, it's okay. Bad decision to use dark mode. Everything is so black. I will make it brighter next time. Bear with me. So you can see that this returns is a very JSON kind of format. So for those who are not familiar, JSON is a structured response that devs like to use. What you need to do is that you need to extract data from the response. So, for example, if I want to know the fee is 0x ABE F777 blah blah blah, and this is in hex. So hex is not something that we work on a day-to-day basis. So you need to copy that, and you need to type in Google hex to DEC converter, and the first result, and you just paste that in, and you see, oh, okay, this is the value that I'm used to. So that is alone it's a work, right? It's a bit tedious, but it's still doable. And again, and if you want to know, like, oh, okay, what contract am I interacting with? Okay, you get the contract, and then you make another call. And in this case, in Starknet, get class add, and you are able to return, and you are able to see like the ABI of the contract. So again, you can see that this is probably not the best experience. If, let's say, Block Explorer would never exist, I personally, in my own opinion, I don't think blockchain will take off, because this is so hard to use. Like, you need to call the data, you need to know how to decode the data, you need to perform multiple actions, you need to call different endpoints. So these are the two of the 30, 40 endpoints that are available. So you need to be creative, play around with this. So it's what the TLDR. It's tricky, it's hard, it's time consuming, it's not efficient. And I haven't got to the point of ERC20 token transfer yet. And what about analyzing DeFi protocols? You need to make even more calls. You need events. You need to decode events. You need to understand what an event means. So some event comes in certain order, and you need to know, like, oh, okay, what does it mean if this one comes before that? Doing those manually by calling the RPC endpoint and reading off from the response like this, it's going to be so painful. Trust me, you do not want to do that. You could try. I don't encourage that. So yeah, there you go. World without Block Explorer, pretty painful. Probably not what you want to do. And Block Explorers are very essential and a very key component of blockchain. Basically, every successful chain will want to have a Block Explorer. So I want to give a brief introduction as to why Nethermind is building a Starknet Explorer. One of the reasons is that Nethermind is an early supporter of Starknet, and we build tools aside from the Explorer as well. One of our other very successful product is Juno Client. So it allows you to run a node on the Starknet ecosystem. And it's written in Golang. That's another product we built. We also have various products, and if you want to know more, feel free to talk to me about that. And Explorer, like I said, is a very major component in a striving and thriving blockchain. We definitely need that. So someone has to build that. And in this case, the Nethermind team decided to do that. So yeah. And one thing that's super important is that Starknet is different from your classic EVM. So Starknet is not EVM compatible. And thus, the Block Explorer will be different from our Etherscan that we know and love of. So basically, Etherscan do not support Starknet out of the box. So in other words, we cannot have Etherscan. So someone has to do the work. So Voyager is here, right? So now, let me take you to the present, the world with blockchain, Block Explorer. This is how it looks like. Nice, very futuristic. And included with a cute meme. Let's explore with Voyager. Let's explore blockchain with Explorer. Let's explore Starknet with Voyager. So I'm going to give a slightly more complicated example than the last one I gave. So let's try to analyze a swap. So for those who want to follow along, I should have included a QR code. This is the link of how a swap look like. So the first thing that you come to this page is that you look at the transaction detail. So basically after a swap, you'll be given a transaction hash. The first thing you do is to click on it or you copy paste. Search in Voyager, the first page that you will be, how can I say, you'll arrive at, it's the transaction detail page. So the very first thing that I personally notice are that, hey, these tools are no longer the hex data that is human readable, not very human readable, and not very easy to understand. So one thing that Block Explorer does is that we do name taggings. We give certain addresses that are well known a name, so that every time you come to an explorer, you know that, hey, look, the two address that I'm interacting with is in this case SIFSwap. So I roughly can know the gist of this transaction. Someone is trying to perform a interaction with a SIFSwap, and there's a transfer of USDC. Because in the world of the blockchain, there are many tokens. In this case, the USDC and ETH is being involved in this swap. So that instead of having to read the 0x address, you will only need to read human readable names, like SysSwap in this case. So very cool. And of course, there are other details, but I won't go through them one by one. The next thing you can do is that you get to know who is the sender. So the sender address in this case, because there are so many senders out there, so most of the time it will be greeted with only the hash. But if you are someone who's well known, like Vitalik, and Vitalik address is made known, the Voyager team will give this address a name, and then you will also have the same experience at the name tagging. And of course, you get to see like how long ago this transaction was made. Which could be important because you kind of want to know, like, for tax purposes, like, when did I perform this transaction, and how do I report tax, and so on and so forth. So timestamp could be important for you, depending on your use case. And the next thing to do is you're able to analyze. Okay, so if you scroll down from in the same page, you can see the function calls that are involved in that transaction. So in this case, it's actually multi-call. So the first thing you see is that you get to know the name of the function that you are interacting with. So to first perform a swap, you need to approve the token. So you get to see this transaction is calling the approve function of the Stargate ETH token, so that I'm approving the spender to spend our ETH token, to spend this much of ETH token. If you were to click on the decimal tab, you get to know that, okay, this is the amount that I'm approving this spender to spend our token on our behalf. And the second transaction, the second function that is made in the same transaction is called swap exact token for token supporting fee on transfer tokens. So this function name is pretty explicit. So you kind of know that after approve, you're performing a swap, and you know that it is supporting fee on transferring token. And these are the input details that comes along with it. So the things that normally people would be interested in are the amounts. So in this case, it's hex, but you can convert them to decimal, and you're able to see that in this form. So this amount is being used to buy this amount of ETH. So why do I know this is ETH and this is USDC? Because I remember from my previous slide that like this part, and this part. So use that to infer that these are the two in and outs. And for those who are more interested in how the route of a swap looks like, this is the routes that you take, because in the world of AMMs, there are liquidity pools, and sometimes you need to make multiple hops. Sometimes for a better price, sometimes sometimes because some pairs are not available. So these routes will be needed to be specified to use this function. And it's very clear. You can see that the from address and to address of each hop. Yeah. And finally, we have the swap token. Oh, all right, this is, yeah. Oh, no, hang on. Okay, this is something that I talked about before. Okay, and this is a clearer view of how a route look like. Yeah, okay, so that's how a transaction will look like. And one thing that in a transaction, one thing that you may want to understand is the events, because events normally 5 more minutes. Oh, adjust the light. Oh, okay. How much time do I have left? Oh, it's much better, but how much time do I have left? 6 minutes? Cool, thank you. So we have events. Events, this is the same transaction. Events will let you know like what happens in the state of this transaction. So we can see that in this transaction, the transfer, execute, swap, sync, fee, blah, 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 is being recorded. So events could be useful for you if you are running your own indexer. You want to use events to improve the UX for users. And this is also a good way for maybe people who understand more about the protocol to quickly understand how exactly this transaction is being done, the internals of a transaction. So events are a good way to do it. Oh, it kind of messed up the thing. So let's look at the swap contract. So I was talking about the transaction. So let's click into the contract and look at how it looks like. So right away, in the contract page, we are given, we can see the class hash and the type. So type is something that we identify because type is already based on the ABI, right? And to really identify the ABI, you have to like look into the ABI code and know that, okay, these are the functions that we have, and is it ERC20, ERC71, so on and so forth. And in Voyager, we have already done that for you. So without having to look into ABI and analyze it for itself, we know that it's ERC20, and this contract is ERC20. That's a very convenient way to let you know the type. There are other types as well, like ERC721, 1155. Is it a proxy contract or not? Is it an account contract or not? And of course, in the world of StarkNet, there are concepts of classes. So we also have the class hash being displayed over here. A class hash basically represents the logic of a contract. And if you scroll down for a bit, there are multiple tabs, but today we are going to focus on only a few. The code, which you'll see the contract ABI. If it's verified, you get to see the source code. If it's not, it's like that. And of course, the class hash. And of course, for people who also want to interact with the contract, you can directly read the contract from the read and the write contract tab, meaning that to interact with the code, you interact with the contract, you do not need to write any code. It's a very quick way to test your contract, especially in testnet, or you want to be fast. So I've known people who uses this to front run people in a protocol that doesn't have a front end yet. So probably that could be you. Messaging is something that is unique to layer 2s because basically there's an interaction between layer 2 and layer 1 via the bridge for a couple of reasons, such as bridging tokens, and they kind of extend that functionality to also bridge data or messages, depending on the use case. So in this case, I only show like a list, and in this case, they all happen. Oh no, we show the direction, like L2 to, either they are from L2 to L1 or L1 to L2. We show from the from contract and the to contract. So when it's L2 to L1, the from contract, it's a layer, it's a Stargate, it's Stargate, one of tokens. We should probably highlight that better. And the to contract is the layer 1 contract address that's on, in this case, mainnet. And this page will be revamped to have improved user experience. So I'm not going to talk too much about this one. And if you click into the message, you're able to see like the content or the payload of what the message is trying to do. In this case, it is a bridge transaction. Why I know is because I scroll a bit down. I scroll down a bit more, and we actually identify for you if this message is a bridge token or not. It's a bridging action or not. So in this case, it's trying to withdraw. Trying to withdraw how much? 0.000003 ETH to mainnet. It's trying to get out from Starknet with this small amount. And one thing I really want to highlight is that we have analytic tools. It's a good way to understand how the network performs. So one of the more famous graphs are like the transaction queue, because it kind of shows like how busy the network is, or how long do you have to wait for your transaction to get included. So this could be a good metric should you want to be quick. Of course, there are multiple charts over here as well. Not going to go through all of them for time reasons. And so Voyager, you kind of have to scroll, you observe, you explore with the UI and the data that we have prepared or indexed for you. But hey, wait, sometimes you are too lazy to scroll. So why do it manually when you can do it via API? So one thing that I really want to highlight into this session is that we have API support, and it's on beta release, and this is how the doc looks like. And for those who are interested, I have included this QR code for early access. So I'm going to leave it up here for like for some amount of time. But again, let me know if you would like to get early access. I'm more than happy to let you try it out. I'm going to just drop it here for like slightly longer. Actually, I see some phone scan. Okay, very cool. I see that everyone has scanned. And finally, I'd like to thank everyone, and happy to take questions. Do you have a question here? Okay, here's a question. Do I walk over, give him the mic? Oh, he has another mic. Fantastic.
Sorry.
Okay. Let's give you a couple of minutes.
Hello. I think as we all...
Is it working? It's not working?
As we all know that in Starknet there are two major explorers. One is Voyager and the other one is Starscan. And although I'm a big fan of Voyager, but without being biased, why do you think that a user would choose Voyager over the other alternatives?
Okay, this is a very interesting question. First of all, I really think that it's important for an ecosystem to have not only one explorer, but multiple competing explorers. In the world of Ethereum, we are very used to Etherscan. But what happens if Etherscan is down, but the network is not down? So imagine that users might not be technical enough to understand that the chain is actually up, but the explorer is down. And then you may assume that Ethereum is down. But it's not. It's just probably Etherscan going through some maintenance. So having multiple competing explorers not only forces us to innovate and also to push ourselves harder, it also is good for the users, because if one is under maintenance, the users can switch over to another explorer. Even better is that we can coordinate our maintenance schedule. So that way, the liveness of the explorer is guaranteed. So as to which one to choose, one over another, to be honest, I don't really have an advice. Also, it's not very fair. It's very personal. Because in Etherscan you are being forced to use one design. So in Starknet, we are being spoiled by multiple explorers. So if this design could be something that is more useful for you, it could be for you. And again, explorers for everyone. So there's no way to cater for everyone. So having multiple explorers sort of helps in covering like the gaps. Like, right? So for example, 80% like this design, but 20% do not like design, they can go for another explorer. So I think we kind of complement each other in that front. Not only in the liveness of Explorer on the network, but also in how we display data. And I think that having multiple explorers sort of like covers the entire area so that everyone is satisfied. Hope that answers the question.
And one more.
Yeah.
Does Voyager have a unique features that other explorers don't have?
Unique features. Basically, the unique features are, this is a good one, are very, subjective and also dynamic. I say that because Web3 is a trend. So back in the days where ERC 721 wasn't there, There's no need to build features for ERC 721, but now ERC 7 is there is need to build that feature. So one thing that Voyager strives is that we observe what the community wants, so feedback is very important, and we'll try our best to build something that helps you to visualize the block data. Unique features, at the end of the day, they are the data that the user wants. So if you want something, feel free to request. My DMs are open, and you know how to reach me. Thank you so much for the question. Any more?
Thank you.
Thank you. Any more questions? Oh, we have one more over there.
I'm gonna ask something a bit technical. So, can you give me like an example of data that are very hard to aggregate or get without like the help of an explorer or an indexer to mediate? So, most data you can get directly from the node. Like, what are examples of data that are extremely hard to aggregate just by querying the node via RPC or something like that?
I think that's a very good question because it's something that people don't think a lot about. People take it for granted. One thing is that I want to view my past 5 transactions, right? So to view my past 5 transactions, we do not know which block the transaction has happened. So to do that manually, you need to like loop through the block from the latest, like block 100 is the latest, you look through 99, 98, 97, 96, and to go through each of the transactions to see if the from address belongs to me. So for each call to the block, you need to make a call to the transaction to get the receipt, and you need to read if that transaction from address is from you. So doing that manually is probably going to be super tedious, and in the Explorer, it's just one page. Oh, this is my five transactions. They're being like shown, and yeah, hopefully that answers this question. That's one example, one easy example that I can think of right off the spot. Yeah, thank you. Thank you for the question. I guess we're done. Very cool. Thank you so much for your time. Thank you so much for your attention. And thank you so much to the Door Labs team for organizing this fantastic event. Pleasure to be here. Thank you.
Thank you, everyone, for being here today. I hope none of you is going to be in Singapore next week. Well, if you are, I'm sorry, the presentation is going to be kind of the same. So sorry in advance. But yeah, thank you, obviously, to Door Labs team and to everyone for making it here. It's a bit of an exodus. All right, so I'm going to try and give you a little bit of an introduction of what we built with ZKX. At least from a technical standpoint of view, we've been working for 2 years with the Starkware team. Practically from 2021, we started working with Cairo. So that's been quite a journey, as you probably have imagined, from Cairo 0.1 on the way to Cairo 1.0. But, you know, what do? We're building a DEX, right? We're building perpetual swaps. And when you come to think about, you know, that particular problem, you have to realize that very quickly, obviously L1 doesn't work for that. You have, let's say, the blockchain trilemma, right? You have the security and trust, you don't necessarily have the scalability, which means that, okay, let's try L2. And then you realize, wait a minute, it's not enough. So then you think, okay, L1, L2, should we be L3? And that's what we're going with ZKX. Right now, not many people know these, but everyone's talking about the TPS of, you know, the L2s and how great it is. Well, Binance does 6 million TPS on a peak day. We're doing 100 at best on L2s and L1s, right? So if you think and compare that, you realize that all of a sudden, even though the monetary layer is on L1 and L2, the actual scalability and computation cannot be there. And that's what we're trying to solve with ZKX. So that's one of the basic problems. And the other layer there is to it is the actual users. Last year at the conference, StarkNet CC in Paris, I did say something that might have come across as slightly controversial on the stage, which was, if we're betting on StarkNet's users and liquidity as our success as a protocol, we're going to fail. What I mean by that is that we cannot just be fishing for what liquidity is there on Ethereum. We actually need to start bringing real users from the real world. And in order to do that, we need to leverage account abstraction. We need to go out there and actually build the bridges to bring these users on board in an experience that will be better than that of a centralized exchange. And that's what we haven't had in DeFi until now, pretty much. So, as I said, ZKX is a protocol. We are leveraging account abstraction to actually try bring a more easy experience for users. No bridging, no complication in terms of trying to use third-party wallets. We have our built-in account, StarkNet account onto the exchange, and we have our own L3 that powers all the functions. We also have our own bridge, actually. So the ZKX L3 performs all the arbitrary computation that we require to scale the derivatives protocol. So that is the funding rate, order matching, and then obviously validation and verification and settlement of those trades. So we have our own internal ledger that we build with Substrate. Some of you may know that, well, there's certain future compatibility of Substrate within the StarkNet ecosystem and other ZK rollups like ZK Sync. So we think that's a future-proof solution. And that allows us to very transparently show to the world and users that the software update has to happen. It basically allows us to say, okay, whatever happens in the order book is transparent, and we're not front-running, we're not selling your order flow, we're not one of those perps that keeps an Amazon server running and you don't know what's happening, on the background. You can actually see it in real time, whatever's happening on the L3, and you can verify that, okay, my trade was matched, was settled, this is the outcome of the trade. This is what's happening with my profit or my losses. And obviously, there's its own consensus algorithm within Substrate, which allows us to plug in the validators and decentralize in the future. And another important aspect of these is prices. I'm sorry, but oracles are slow as hell. They're not really functional for a high-speed environment, which is what you require in an order book. The beauty of having your own L3 is that you can actually, implement your own internal oracle, and you can actually plug in price feeds directly from centralized exchanges. It means you can list assets faster. You can also provide faster price feeds. So I'm not going to go into the whole architecture here. Might be too much for this talk, but happy to talk in detail if you want later. But in short, all the monetary parts are on StarkNet, so we maintain trust and security over there. Obviously, insurance fund, liquidity fund, and so on. And then everything that deals with the order book, prices, and all the algorithms, whether it's rewards algorithms, funding rates, and all, everything that really has to scale is going on the L3 along with the entire substrate layer to verify and maintain consensus. So I think that's the basis for what we're doing with ZKX on the L3 side. There's some other aspects we're building, whether it's Starkway, which is our own bridge from L1 Ethereum to StarkNet. The reason we did that, and we actually been working with Starkware a little bit back and forth on improving Stargate in the future, but we needed to have a very simple way to onboard users, integrate cross-chain SDKs into the ZKX account, and so on. And that is facilitated by our own bridge, which is being audited by Nethermind, actually, as we speak. And the bridge, the advantage is not only gives us a little bit more autonomy in terms of onboarding and creating, a more powerful account features. It also provides us, a very simple way to do, something that's going to happen now in September around the ZKX protocol, which I cannot reveal right now, but yeah, it will require a bridge on mainnet. So just a little bit of alpha. And yeah, we talked about the ZKX account, so no news there for you. As mentioned, ZKX account is powered by the Starkware bridge, and we envision a future where we abstract the entire rollup experience. So from our perspective, it's not about the user has an account on a particular rollup, but in the future, it's going to be more about what's the best rollup to keep liquidity in terms of security, speed, transaction fees, and so on. So, if we're talking 3, 4, 5 years down the road, L2s will probably be abstracted away as well, as L1s are going to be, in a certain sense, for the end user. And that's where, a kind of abstraction can be leveraged. So in the background, you may have different accounts for the user and different rollups, but it just shows as a single pool of liquidity for the user in their account. Now, when you're talking about traders, you have basically the supposition of, let's say the Bell IQ curve, right? We all see on Twitter and we all laugh about, right? The mid, the high IQ and the low IQ, right? And you always see the low IQ and the high IQ kind of agreeing. And the mid IQ is always the one that gets, liquidated. Why is that important? Because you realize quickly when you start building a front-facing B2C product is that you have an entire sector of users that don't really know how to use these sophisticated trading tools. They need very simple trading experience. Everyone was laughing at PancakeSwap when it came out, right? And everyone was laughing at BSC. But reality is they had a ton of users using them, because they had a very accessible user experience. And that is something that we need to think about in terms of growing in the future. You need to offer APIs, complex trading terminals for the advanced users and institutions, but you also need the retail to have a fun experience and stick around, because at the end of the day, they're both sides of the order book. So I'm not going to go into the high tides and the quests. These are different algorithms and features that we are implementing. The technical papers are going to be released very soon. But it brings why high tide matters. When you really need to think about, right? Until now, we just give rewards for volume. And that basically ends up being, owned by the institutions. You need to have a very precise way to value a market participant regardless of their size and regardless of the amount of collateral they're putting, right? Someone may be trading every single day 1,000 times. Yeah, there's people that are sitting on their bedrooms in different cities around the world that are doing millions and millions of volume of trading with very small amounts of collateral. And these people matter a lot for us in the long term to be sustainable. So that's why you need to provide more accurate reward algorithms. And why does this matter for us? It matters because when you approach the DAO and the governance, to be honest, governance tokens are dead. Who cares about governance tokens? I mean, at this point, A60 and Z buys Uniswap tokens, they do whatever they want. And they want to decide what happens with the treasury, even though it might not be in the best interest of whoever is using Uniswap every day, or the power users of Uniswap. So that's why we feel there has to be a way where you value a market participant, and then you assign them voting power in the DAO. And that voting power is not tied up to the token holding. It's tied up to your contributions to the protocol. And that's why we need an algorithm that measures that. So that's how we tie up the entire system. And we call this liquid governance. It's going to go live next year. We're still slowly building it because you kind of need to model, in our case, a hybrid system where you do have a live token and you have traders and users that also require voting power in the DAO. But, we envision that someone could take these smart contracts in Cairo and actually create a DAO that doesn't need a token, but still is able to award representation and voting power to the users of the protocol, and have decay according to the users, soulbound, all these different concepts are built in actually. So yeah, we already talked about liquid governance and digital shares. Token utility, trading rewards. It's fine. You can come talk to me. Just to end the presentation, we had this crazy thing called the ZKX Yakuza, which is kind of a fictional universe we created with characters and a story fixed in the future. They need to go and recover the Ethereum beacon chain because the governments have taken over and destroyed, everyone that was running nodes for Ethereum. And that kind of story went wild. We launched the entire campaign on Zili, what was used to be Crew3, and we had more than 1 million quests completed in 3 months at the beginning of the year. It was insane. It was crazy. We had more than 37,000 people joining in. People loved it. So we're going to have a Yakuza NFT collection coming up very shortly. And that's going to launching natively on L2, by the way, on Starknet. So it's going to be a full NFT collection on Starknet. And it's going to drop on the ZKX, certain ZKX something that's going to go live as well. And I cannot reveal too much. But that gives you a lot of understanding how much we're focused on regional. Someone asked us, I think a few months ago at an event, it's like, what do you think about the narrative of emerging Asia in crypto? And I was like, are you kidding me? I'm like, Asia has been crypto from the start. Look where all the exchanges were born. Look where all the trading activity was born. It's just by default. So maybe it's a little biased that, some communities may have, in Europe and so on. But for us, it's always been very important that we approach everything we do in different languages, in different local communities, building local chapters. And we think that's going to be the key for growth for ZKX moving forward. And I'm not sure I should show this. I hope no one releases this. It's a bit of alpha. So we're doing the second audit with Nethermind. And we're going to do the testnet 2.0, a new season of the Yakuza. And we're going to launch the NFTs and our first product on Starknet mainnet, all within the next 3 months. Yes, we're not sleeping. And Q1, token listing, mainnet launch. We're going to go live with a full exchange. And then we're going to head into the full DAO decentralization part. If we have any neurons left in our brains, I hope so. All right. Thank you, folks. Thank you for coming today. Any questions? No? Want to grab the beers outside? Yeah? All right.
Hello. Hey, everyone. Nice to meet you. This is Vince from ZK-Link. This is our first talk inside the Starknet community, and I'm very excited for the progress that we have made together in the Starknet ecosystem. As a part of the Starknet developer community, also as part of the one of the earliest teams building with Carol, we're here to share the recent progress that we have made using Carol language, and also how we aim to unite the ecosystem of Ethereum Layer 2s with the Starknet. So I'm going to spend the next few minutes explaining what ZK-Link is trying to achieve, trying to build here. We are building a secure, efficient, and unified trading execution layer that aggregates liquidities across rollups and also across blockchains. The 3 major problems we're trying to solve is liquidity fragmentation, which is going to be a bigger problem with the emerging layer 2 ecosystem mature in the future, with this new layer 2 ecosystem become more developed and a lot of new applications with liquidities and also users abstracted down to different layer 2s, we can imagine that there were going to be a liquidity problem, right? So you would have to move liquidity frequently from one to another, and then you either do that through a bridge, either you have the new types of infrastructure like the one we're building to aggregate the liquidities, and unify liquidity is easier without using a bridge because it's complex. So the navigation through these different ecosystems is complex, and it's not user-friendly. And also there's a security risk associated with bridges. Some of the features that we're building onto the protocol are like, we want it to be easy for developers to use. So we're building this, we're offering high-level APIs for developers to quickly deploy their applications and with access, native access to multiple blockchains, multiple rollups. And we're allow users to customize the APIs, customize the features, customize their needs for data availability, customize their needs for network collections. I'm going to extend to that later on. And we can support several types of use cases, but they are all focused on they are all basically trading focused. For example, CLOB, central limit order books, RWA derivatives, NFTs, AMMs. So this is a graphic that can give you a very rough overview of the network structure of ZK-Link protocol. There are several types of applications that we support, and then within each of the ZK rollup network deployments, there could be 1 to several applications using that setup. For example, one application can choose to deploy on Ethereum BNB chain Starknet, which represents Ethereum to solve and Ethereum rollup VM and EVM compatible outer layer 1. And another application may choose to deploy solely on Ethereum rollups, like optimism rollups and ZK rollups. And another application can choose to solely deploy on Ethereum ZK rollups, like Starknet ZK Sync, other ZK EVMs. But they among all these different setups and deployments, they can share the service through a recursive verified contract, so they can share the cost of generating a proof and verify the proof. The types of networks that we support, we have briefly explained, including Ethereum Layer 1, EVM compatible blockchains, even Layer 1 EVM incompatible blockchains like Solana. We have completed the Gross 16 proof contract on Solana, but we have post work there since they do not support SHA-256 for Plonk proof verification. And we also support ZK EVMs. We're live on ZK Sync and Linear, and we're working on Polygon ZK EVM and Scroll, Tyco, etc. And also we have included OP rollups as well. And we have just launched the testnet on Starknet, which represents ZK rollup VMs, EVM non-compatible. For developers, they can choose their deployment of network collections among these 3 types of networks that we support. We have highlighted here the ZK rollup VMs deployed on this Ethereum mainnet because our thesis is very much Ethereum-centric. We believe that the future of blockchain will be, especially the DeFi applications, will be Ethereum-centric. Most of the liquidities will be staying on Ethereum and Ethereum rollups. So we'll be moving from where we are today, the deployments of outer layer 1s plus layer 2s, which will make us a hybrid model of layer 2.5. And we're gradually switching to a layer 3, multi-rollup layer 3. So we'll be settling transactions on layer 2s, including Starknet. This is one example of network collection scenario that the application could choose. Here you can see that this application chooses to deploy on the BNB chain, Ethereum, Starknet, and the validator, prover, and sequencer system, the off-chain services will be posting the proofs to the contracts deployed on each of these different networks. And then as you have outer layer 1s, then they cannot directly talk to Ethereum, then you need third-party independent light oracle services to synchronize the states through the final routes. As this validator system is posting the proofs to different chains, and then you need independent service to synchronize the states of these state routes to mitigate the risk of conspiracy, because you don't have to trust any a validator system or other chains, but with the help with the light oracles, these light oracles can be any generic messaging service like layer 0, Chainlink, or you can be some stakeholder in the ecosystem like a market maker. They can run the program themselves as well, so they don't have to trust anyone in this system. I just mentioned that we also provide customizable solution for DAs, so you can application can choose to deploy their data availability to one of the networks they connect to. We call it the internal DA. For example, one application has deployed on Ethereum, Polygon, Starknet. They can choose one of these three to store the data to perform as a DA. And also some external DA like EigenLayer, like Celestia, and also they can store the data off-chain. Starknet has talked about like a data community off-chain. Well, this is one of the options. And also it can be a mixed model between these two. There are some roles of in the ZK-Link ecosystem: user of the applications, application developers, and community participants, including validators, provers. I think you are all very familiar with this because this A-Link ZK has these roles in the ecosystem. And we will go into decentralize the validators and the provers also in the ZK-Link ecosystem by through a token incentives, and also ZK-Link core contributors that are right now developing and iterating the codes. How developers can use ZK-Link protocol is they can simply just deploy their applications by using the APIs, by calling the APIs. And on the website, there are detailed examples and instructions of how to use these APIs. And for customizable deployments for some specific requirements from features, for example, an order book DEX may certainly wants to build some specific financial features which they need help of the core devs to realize or to build those features into the circuits. The devs are writing the circuits using RCES, so very low-level language, machine language, to build the circuits. And the circuits is certainly smaller compared with generic ZK like Starknet. And these types of orders and these types of opcodes of this written by RCES is more efficient, much more efficient compared with the opcodes built by a higher level language that we ultimately interpreted into Solidity, into Cairo, and all other languages. The reason we're doing this because we want to build these trading specific features that will be more powerful and efficient than that you could do using a generic language. Otherwise, it won't be competitive. And right now, we support the functions of spot trading, derivative trading, perpetual contract, OFT minting trading. Very soon, in Q4 this year, we'll have NFT issuance trading and RWA derivatives covering different asset class. And some of the recent updates of the project, we have performed the first ever in industry the asset recovery test on the layer 2 level. This is showcase the real security boundaries of any layer 2 networks. We have done this in May this year, and there are over 100,000 zero-knowledge proof generated. And yeah, we helped more than 50,000 users recover their funds on our testnet using the data stored on chain. We stored the data on Polygon for that test. And we also have conducted several rounds of security audits of all the smart contracts and also the zero-knowledge circuits. And we launched the alpha mainnet just last month. And right now, users can deposit and withdraw native assets enabled from different 10 mainnets, including Ethereum, Starknet. So our journey on Starknet began in June last year. Our devs started developing the contracts using Cairo 0 last year. And then we deployed the contract V0.1 on Starknet's testnet August last year. And then we started to upgrading the contract from Cairo 0 to Cairo 1 this year in May again, since there's an update of the language. And now we just completed the migration from Cairo 0 to Cairo 1. The V2 smart contract is live on testnet right now, so users can use the StarkNet testnet, and we expect to go live in September on StarkNet mainnet. The migrated EVM contract to StarkNet can enable interaction between other EVM rollups layer 1 chains with StarkNet. And we have developed a specific feature we call bytes. It's similar to the bytes feature in the Solidity language. This data structure is to facilitate the Solidity to Cairo migration. We will very soon open source this for other developers. And there are some other active contributions to Cairo development from our devs. I'm not going to spend time on this anymore. But this is like a little bit more detailed explanation of our work on bytes. So in Solidity, encoded pack they used to design complex types of hash functions. Because to realize the Planck proof verification on StarkNet, we need to enable two functions. One is kcac, and another one is called SHA-256. These two hash functions using the Cairo language is not very difficult. So our devs have developed this specific data structure to enable these two functions to verify the SNARK Planck proof. This is some details of bytes. It's a dynamic array of U1 to 8, each element containing 16 bytes, extensible to 31. The byte size is adjustable based on dev community feedback for most needed use cases. And we have used this to enable easy kcac 256 hash calculation for token type structures in both Solidity and Cairo. On a very high level, we want to provide an infrastructure solution that makes it easy for DEX developers to build scalable and secure applications on multiple blockchains and multiple rollups, especially rollups. We're gradually shifting from multi-chain to multi-rollup layer 3. And considering the future, this is a very simple graphic showing the layer 3 structure of ZK-Link multi-rollup. We're going to post the proof, state proof, where the ZK-Link off-chain service have a unified state tree to record all transactions across different ecosystems. And then the validator is going to post the proofs together with the state proof to different layer 2s ZK rollups, like including obviously StarkNet. And then the contracts of these layer 2s will post this message to Ethereum through the official bridge service, and then settle ultimately all these funds and transactions on Ethereum. So everything ultimately is settled on Ethereum and secured by Ethereum. So it achieves the same level of Ethereum itself. There's absolutely no compromise and degradation on security in that sense. But still, through this, we'll be able to abstract and aggregate liquidity, unified liquidities across all the ZK rollups. So pretty much ZK-Link is working for a rollup-centric multi-chain era that we believe is coming very soon. And we enhance the layer 2 ecosystem by unifying liquidity, by simplifying cross-rollup user experience. And our aim is to add value and unite the Ethereum ecosystem with ZK snarks. So we're happy to explore more synergies with all the ecosystem projects. Thank you very much. And we're running a summer tour to help users to explore different layer 2 ecosystems. And if you're interested, you could take a look here. And thank you very much.
My name is Danilo. I'm co-founder and ecosystem lead at Kakarot. And today I'll just share a little bit about what is Kakarot, what we have been working on, and what are our future plans. So just an intro, Kakarot is a ZK EVM. It's basically an EVM written in Cairo, which makes it provable. So before talking about Kakarot, why ZK EVMs? Why not ZK EVMs? For those who have been into ZK, you might already know that some of things that are very fast on a normal bytes 0 and 1 computing is not so fast on polynomial computing. And that's the reason why StarkNet built their own ZK VM. They built a virtual machine or a blockchain that is very ZK friendly. But in our case, we decided to build a ZK EVM because we believe that Ethereum is a thriving ecosystem. There's a lot of toolings, a lot of great developers and projects already ongoing, and we want to be part of these movements, not just by scaling Ethereum, but also by being able to integrate with all these toolings. So, I shared a little bit. Just the trade-off between ZK VMs and ZK VMs that a pure ZK VM would be faster and more efficient than a ZK VM. But a ZK VM have the network effect. You don't have to onboard new users. You don't have to have them learn something completely new. They can just build what they are. They can just use all the toolings they're used to and just migrate to a ZK VM. So this is a very simple overview of Kakarot. Basically, Kakarot, you can see it as a smart contract on StarkNet, which will receive an EVM transaction or an EVM raw data, and then they will have the contract logic will interpret, run the bytecode as a smart contract, which will be then processed by also the StarkNet OS, generate the proof, and then verified on L1. This is a very simple overview of the first version of what we were thinking about Kakarot. But right now, Kakarot can, besides this, can also become an L2 or L3, depending on which sequencer we use, or if you really want to be on StarkNet. The idea first was also that Kakarot would allow Cairo and StarkNet's contract interaction within the StarkNet ecosystem itself. Some of the perks for Kakarot, comparing with other ZK VM teams, is that on Kakarot we focus fully on implementing the EVM, and we don't. Of course, we study and we learn about the ZK part, but we don't have to implement the ZK, which is done by the Starkware team. The Starkware team already have a ZK technology that has been proven since 2018, with more than $1 trillion being transacted on their circuit. So it's a very battle-tested technology, and we are basically building a ZK EVM on top of it. Even the StarkNet OS, it's an OS written in Cairo. So instead of having a StarkNet OS, we are having an EVM OS, we could say. A little bit about Kakarot's story. We started as a fully open source project. The project itself, the idea itself, was shared by Shahar, who is the one of the co-founders or the co-creators of Cairo. Last year, July, he said it would be possible for someone to write a ZK EVM in Cairo. There's the tweet. He mentioned that there is a repo that he already started working on. We never got to see that, but later that year in October, we were preparing for the ETH Lisbon hackathon and also a big StarkNet hacker house. And one of the projects that was proposed by Abdel was, hey, why we don't do this project that was proposed by Shahar in July. And then from there, me, Elias, Clement, and some other developers said, hey, let's do it. And we started contributing completely open source. And then we had a team for ETH Lisbon, and that's where Kakarot started. From there, three of the 5 members who joined Kakarot at that time became co-founders, and here we are today. This is just one funny story about the Kakarot in the beginning, is that when we were in the hackathon, we were doing things really fast. And there's a difference between StarkNet address and EVM address. The EVM address, they are padded only 20 bytes. The StarkNet address, is the full thing. I think 31 byte. So there's some difference. And then we had to create this function that will make a EVM address into StarkNet address and vice versa. And then we did, okay, all the contracts in Kakarot will start with Abdel, OXABDE1. And for the hackathon, all the Kakarot contracts had this. It was pretty funny, but now we don't have any more. But there was a very funny story where, like, because of this, it helped us debug like 3 or 4 hours before submission. We were having this bug where we couldn't figure out what's happening. And then we were like, oh, wait a minute, this contract, it's not Abdel, what's happening? And then we were able to track back the issue. So just a little bit about Kakarot community. This is definitely a project that wasn't just born by ourselves. It had contributions of more than 30 developers on the StarkNet ecosystem. I would say that it was like one of the first big projects for the StarkNet community to come together and build. Right now there's Madara, there's Birus, there's Tsubasa, there's a lot of projects, even Dojo. I think Dojo was actually before Kakarot. But like the community coming together and implementing a lot of things, it was pretty amazing to see the early days of Kakarot. And now, where are we currently at? This was on Cairo 0. Since then, we have incorporated. Some of these contributors join our team full time. Some are still contributors. And now we have 6 months since then. We now have a whitelisted testnet ongoing that we opened since Paris to have some initial developers trying out the Kakarot pre-alpha testnet, I would say, because we are finding a lot of issues. We have been able to integrate with EVM toolings, Ethereum toolings, which was our goal from the beginning, to be able to integrate with all the toolings that are being developed in the Ethereum ecosystem, even though we are using a StarkNet node. So right now you can integrate with Kakarot using MetaMask, Remix, Foundry, Ethers.js. We are already trying out Hardhat, Veeam, Trufflebox, WAGMI, and all the others EVM tools. So it's really fascinating. When we first got the MetaMask transaction on Kakarot, we were like, oh, this is so like crazy right now. We are using MetaMask to make a transaction on StarkNet. And when you would see if your transaction went through or not, you would go to StarkScan or Voyager, and it felt like a bit weird, but at the same time very funny. Like, you're using Remix to deploy contracts on StarkNet. You're using like MetaMask or even Foundry to debug contracts on StarkNet. And currently we are in the migration from Cairo 0 to Cairo 1. I think we had a big jump from the contributors to where we are. Since 3 weeks ago, we've been doing a lot of migration while still debugging the older version, debugging the logic. And right now we are open to open source contributors. So if you're interested in learning Cairo 1 and about EVM, you're more than welcome to come join us. We are also making sure that our exploration and things that we find out on how to optimize the code is shared with the community. So we are trying to do some research on, like comparing loops versus recursion in Cairo. What are some of the things that Sierra brings that there wasn't possible in Cairo 0? So just some simple findings. For example, right now, if you use structs in Cairo 1, the Sierra will optimize some operations for you. For example, Cairo is a read-only memory format. So if you want to update a struct, what you have to do is like you have to create a completely new copy and just update that variable that you have. Let's say you have variable A, B, and C. If you want to update C, you have to copy A, B, and then just change C. So every time you wanted to update a new struct, you need to make the entire copy. But right now with Sierra, let's say you change B and C. Before, you would need to copy it twice, but now you only need to copy once because the compiler, Sierra, is optimizing. In terms of always use inline, there's a feature in Cairo, which is you can make it as always inline, which basically what does under the hood is you copy that code snippet into the other functions that you're calling, because when you're calling some function, there are some extra steps. And when you use always inline, it makes the code bigger, which the deployment will be more expensive, but your code will be more efficient. And besides this, we do some other explorations. If you want to check out our repo, and you see all our findings on Cairo optimizations. Also, right now we are extensively testing our current testnet, our closed testnet, with following Hive and Ethereum Foundation's tests. Right now, they all have. It's natural that the Ethereum community have very extensive tests for nodes to make sure that all nodes are following the same specs, and all nodes have. If the nodes pass this specific test, they could be considered secure. So right now we are running through these tests, and yeah, that's what we'll be focusing on this last month. We are always open to contribution. If you are interested, you're more than welcome. Everything that we're developing in Kakarot, they're fully open source. There is no line of code that is closed source. Everything is open source. So, and we try to keep all the issues as broad as possible, from beginner, very good first issue to more harder level issues. So if you go to any of the repos in Kakarot, you'll be able to find, you're probably able to find an issue that might be good for you to start with. So when testnet and when mainnet, right now we are aiming to go to testnet this quarter, a public testnet, because we already have a whitelisted testnet. Sorry, my brain is a bit foggy right now. And mainnet, we hope to hopefully achieve by next year Q2. So yeah, if you have interest in trying out contracts in Kakarot, by the end of this quarter, you might be able to already start deploying your own projects. And we might have some programs and some hackathons by then, but to be announced. Okay, if you would like to follow, I think I'm I finished a lot earlier. But if you want to follow us, you can follow us on X, not Twitter. When I was doing this, I was like, okay, I have to update myself. On Telegram or on our website, feel free to reach out. We are open to anyone who wants to contribute in any way. We have also a very interesting Discord group with a lot of memes being generated every day. So yeah, feel free to join us in however you like.
Are there any questions?
Yeah. Will you support SHA 256 very soon? Will you support the realization precompile of hash functions, complex hash functions like SHA 256? That's actually the question that we asked a lot to these EVMs. Yeah, that's.
Yes. So for Cairo 0, we have 8 of the 9 precompiles ready. We just don't have the pairing. For Cairo 1, because they don't support hints yet, we are still waiting for that to migrate. But if you want to look at the Cairo Zero code, which is also provable now that they have the prover open source, you will be able to see that you have the SHA-3 and all these other precompilers too. We don't have the EC Perry. I don't remember all of them by head though. Does that answer your question?
We'll chat about that later.
Okay.
Hi everyone, my name is Sam and I work at Node Guardians. Node Guardians is... I need a spell to buff my charisma skills because I'm totally wrecked. So I'll just try again to compute the next sentences. Yeah, Node Guardians. Okay. Whew, thank you. Thank you for the healing spells. So what is Node Guardians? It is a platform for experienced developers to challenge their skills and achieve meaningful things in the most promising ecosystems, let's put it this way. I like to call it a role-playing game for experienced programmers and security researchers. The flow is extremely simple. You log in with your GitHub or your Web3 wallet, and you have to solve programming challenges that we call the quest. A little bit like in Baldur's Gate or Neverwinter Night or Final Fantasy. There is a story that is tied to each of these quests, and these quests are programming challenges, as I said, and you need to basically achieve something that's specific. You need to write code in order to unlock the end of the story. And based on how your code is, how efficient it is, for example, we could think of something like that, the rewards that you get will vary. And these are proof of skill. You can use them to justify that you're maybe a relevant contributor for that open source repository, like some experiment we've done with the Kakarot team, or you can use it for any kind of logic. You want to hire a smart contract engineer. You can just say, if you're not level 8 on Node Guardians, you cannot really apply for that job because we just want to make sure that all the people that we interview are likely to be relevant, to be fit with our criteria. So I'll be sliding through so you have more visuals and maybe a better understanding of how the whole flow works. So you have a quest selector with various topics that are covered, from assembly to Yule to elliptic curve mathematics or how to implement your own curve to diamonds, a lot of gas optimization. If we're talking about Cairo, you can have stuff about bad accounts, orderless hashing, how to implement your own brainfuck VM on top of StarkNet. A lot of spicy stuff for you to get closer to production level with that language and get ready to do concrete things. That is to say, contributing to open source, landing a job, as stated earlier. So we have 4 types of challenges. CTF, capture the flag, which are fully on-chain. You just deploy the contract, and we deploy in parallel another contract called the verifier, and your goal is going to be to trigger something on-chain, either breaking that contract, stealing the money that's in there, or manipulating the price oracle. Could be a lot of things. We will just be listening to the chain and verify that you have triggered the right thing on the network. Then you have build. Build is when we need to verify a more intricate logic in your code to check if you've used certain methods or if it really satisfies some very specific criteria. In that case, we'll be writing some Foundry test to see if your code satisfies everything, and the whole process will be automatic. Resource management, also known as a gas goal thing by the OGs. You have an optimization problem, and you need to optimize. You need to have the shortest solution to achieve a certain outcome. And finally, theory. So theory is sometimes, if you want to deal with stealth addresses, for instance, you need to be familiar with elliptic curve cryptography, right? So we also try to provide some resources so that you have the right theory assets before diving into more complex practical topics, right? Okay, quick question, nothing to do with Cairo. Who knows the game? Oh, not bad, not bad, not bad. I thought it was not popular at all in Korea. I should have made it more StarCraft related, but yeah, props to you guys. So that's another glimpse at the interface. You know, that's the contract that you're going to deploy, the inputs, some walkthrough elements, and the whole flow is that you don't go through an IDE or something like Remix. We want the experience to be as close to a production environment. So you just set up your own environment and then you're ready to code. That's a design chance we've had with the platform. And it's also a point that's good to note when using Node Guardians. Next step. Oh, the inventory. So here are the proof of skills. Every time you complete a quest, you get soulbound gold, XP, crafting material, and objects that you can use to equip your character. So you could think as, for instance, I don't know, you are the Radius, you're Ave, you're Compound, and you want to issue your own item to filter out people for your own community. You can say, well, if you're not able to do my CTF, you cannot attend to my event, or you cannot apply to that specific job, or you cannot do this or do that. You can think of all sorts of logic that derive from this inventory system. Another cool thing is that in the very near future, we'll be also able to monitor some of the open source contribution that you do so that it can also change your rank in the leaderboard and enable you to craft more sophisticated items. So if you want to have a dragon, well, you need to have that amount of pull requests merged. And by pull request, I don't mean editing the MD file on certain repositories. So yeah, there is a competitive like ranking logic based on your completion in the game, if you're first blood, and very soon your open source activity. And yeah, while solving to basically build some kind of, I don't like to say on-chain resume, but that's a bit what it is. The more elements you have, the fancier armors you have, the best like track record you have, the more solid, the more trustable your profile is, and theoretically, the more things you should be able to achieve or justify with X, Y, or Z counterpart. Okay, so yeah, there's a whole like evolution logic that derives from this, and beyond just being a platform, it's also a community. So we've done some experiments by organizing StarkNet CC with Only Dust, and for instance, if you're a scholar, a mage, or high mage, you don't need to buy a ticket there, even though it's sold out. You could think of a future where if you want to go to certain events or ECC, if you're a guardian, you bypass the queue, or you can like do things in a different way, access our hacker houses without going through the normal process. And it's basically like being part of a community, and there's something we really attach to at Node Guardians. It's a developer wait. I found the block header. It's a developer. It's a public good. It's a public good from the developer standpoint. So no fluff, no bullshit, no ads, and you're part of a community. You have no obligations in the sense that you don't need to do something back or tweet about something in order to benefit from all of these things that I'm listing here. That's also a very important aspect. We're trying to keep it as no bullshit as possible. And each of your feedback are thoroughly processed so that we can make that product better because we want to build it together. So yeah, that's also a very important aspect. We're trying to make the platform as pure as possible so that it caters and attracts more brilliant people like you. And yeah, we also need your input to achieve that. Contribute to open source. That's the interface and the visual representation of your skills, but the V1 is coming in a few weeks. So it will be much better than this. This is a little bit like obsolete. That's an old slideshow. It's not a pay to win, so you cannot like buy some fancy items and do this. The items are soulbound. And yeah, some statistics. We have about 75 quests created. It takes on average 150 hours to solve them if you're a proficient programmer to finish the whole storyline. And each quest is linked to another. So one quest, one character that you find in one quest, you might find it in another. And quests with multiple endings might become a reality sooner than you think. And if you care about the story, that's something that you might eventually enjoy. And we've had 6,000 quests completed so far and 900 active developers. I know that's always a very tricky notion. What does active mean? It means people who have been completing a quest or pushing code over the last like 4 months or 5 months on the platform. Contribution is also a thing. We are fortunate to have contributors from the Ethereum Foundation, ImmuneFi, and also Ledger, other companies that are shipping like pretty beautiful challenges on the platform. So if you want to collaborate with our team and create amazing stories on the topic of your liking, or even if you're running a protocol, you're building some open source, could be something like Matara, you're building like something in that space, and you want to leverage that engine that we've built to I don't know, to any purpose, to recruit, to upskill, or do something like that, we're also open for conversations. And if you also want to join our team and have a wonderful time with us, we are recruiting actively on the engineering side of things. If that's something of interest to you, I'm more than happy to have a chat after that talk. Next slide. Yeah, that's pretty much it. You'll find all the relevant links to engage with us in this patch of text here. And another thing is that your Node Guardians profile, if you want, is linked to your Discord. And anytime you're encountering any difficulty in the game whatsoever, every engineer at Node Guardians is a customer support specialist. So we'll be more than happy to lend you a helping hand. And the community will also be here to help you. So yeah, we have a Discord, fully no bullshit, technical conversations. And we look forward to welcome you there. And I'm very thankful that you stood with me to listen to that talk, really, from the bottom of my heart. It's not easy. And yeah, if you have any questions, I'm more than happy to answer them. Thank you.